Hello and welcome. In this video we're going to look at typical examination questions that ask you to calculate the F-net of objects that are moving or that are experiencing forces that are acting on it. So without much further ado, we are going to show you a question that is taken from the past examination questions that were asked in grade 11 from the NSC examinations, CAPS grade 11 2015 examination. So in this question, you're asked to do the following. It says a constant force F pulls a 50 kg block at a constant speed over a rough horizontal surface. So key words that are important to take note of here is the fact that the surface is rough and it is horizontal, so it's moving along a plane or a horizontal plane, right? So it's rough, so that means there's friction that is acting on the system. And then the object is a 50 kg block. Then AB, that's the plane on which the object is moving. The coefficient of kinetic friction mu k between the block and the surface is 0.4. So we are going to apply that, and this is going to help us. That mu there, or the coefficient of friction, is going to enable us to calculate the frictional force that acts on the block. Remember that the frictional force Fk or Ff is equal to mu k, that's kinetic friction, so which is the coefficient of kinetic friction multiplied by the normal force, and the normal force in this case is going to be quite simple and straightforward to work out. But however, we need to look at the rest of what the questions say. Then when we get to that point, we will apply that. So it says draw a labeled free body diagram showing all the forces that are acting on the block. So in this case, what you have is you've got a 50 kg block. So when we look at the forces that are acting, so it's just so we show the object by means of a dot, and then what are the forces acting? Well, you've got the normal force that acts on the block, and you've got the Fg that acts in the downward direction. So this is your Fn, and then you've got your Fg that acts downwards. You also have, because moving on a rough surface along the horizontal, you're going to have a frictional force, which can be referred to as your kinetic friction, Fk, and then you also have the force that is applied, and that force that is applied is acting at an angle of 20 degrees. So as it is, it's good enough to just show it like that, and so there is your F. So it is also possible that somebody may have chosen to represent the diagram by means of components. Remember, if you choose to use the components, you cannot then give the net force together with the components. So if you choose to use the component method, you would need to say, okay, there's the force, there's the object, and then there is the frictional force that is acting, the kinetic friction acting in that direction, and then you've got the components that are present. So you've got your Fx, right, your Fx component, and then you will have your normal, and then you'll have your Fk, that is your Fy rather. So you've got your F normal, and then you've got your Fy component, and then you will have your Fg acting in the downward force. So it's important that if you choose to show it this way, you would show it in terms of the components that are there, and you would, let me just maybe just put it this way. Oops, that's a straight line, right, same size, and so that's your Fn, and then you've got that, so that force and that force acting in the same direction, then they would give you a magnitude of the force being equal to your Fg. So it's also fine to represent it this way or the other. You don't need to represent both. And then 3.2, the question reads, state Newton's first law of motion in words. Well, Newton's first law of motion, also referred to as the law of inertia, says a body will remain in its state of rest or continue moving with a constant velocity unless it is acted upon by a non-zero or an unbalanced net force. So key words to remember: state of rest, or constant velocity, unless it is acted upon by a non-zero or unbalanced net force. So these are key words to remember when you are giving the law. Stating the law as according to the exam guidelines, you need to learn that. And then it says calculate the magnitude of the force F. Lots of marks there, so that means you are going to do a bit of working out. Then you have to determine the normal force and then the frictional force as well for that. So now let us calculate the first part. I'm just going to create space, or I'm just going to do it on the other side. So you're asked to calculate the force F, right? So we want to know the value of the force F. So we drew our free body diagram. I'm just going to copy this free body diagram and then bring it down to the side where I'm going to where I'm just going to do the calculation. So I will copy that. So it's this, right? Control C, oops, control Y. All right, control C, and then I'll just place this here. Right, so you've got your F normal and you want to calculate that value of F. So what we are going to do is remember this object moves along the horizontal plane. Because it's moving along the horizontal plane, that is what we need to remember. So we're going to work with the component in the x-axis, and that component which is in the x-axis becomes of interest to us. So basically we are interested in that fx, and that fx is equal to what? F applied cos 20, which is the angle at which it is acting. So that force applied is what's acting to the right, and the other one is acting to the left. So if I choose that direction must be positive, and that means the opposite direction is going to be negative. So now, what do I know? I know that I can say my F net for the system is going to be equal to MA. So stating that, which is a given, you will get a mark for it. And how do I calculate my F net? My F net is obviously going to be Fx minus Fk is equal to MA. So my F net is going to be F applied cos 20 minus Fk is equal to the mass. The mass of the object is 50 multiplied by the acceleration. Now in this case you're told that it's moving at a constant speed, so the acceleration is equal to 0. So because the object's moving at a constant speed. So 50 times 0, that would give me the value. So in this case, I have my f app cos 20 is equal to fk. So now my Fk, which is my frictional force, I have not been given the value of the frictional force, but my F-app, so I've got F-app cos 20, I can work out the cos of 20. The cos of 20, if I put it into my calculator, I can just simply state cos 20 is equal to 0.949369, so it's 0.94. So this is going to be equal to 0.94 F, or F applied, F app is equal to Fk. Now Fk is equal to mu k multiplied by the normal force. Now, what is my mu k? The mu is equal to 0.4, so it's going to be equal to 0.4, and then multiplied by the normal force. Now, that normal force has got two components. It's got the normal, and then it's also got the Fy component. So now I want the Fn. So Fn is going to be equal to Fg minus Fy. So my Fg is going to be equal to 50 times 9,8. So that's Fg, that's Mg, minus Fy. The Fy is F sine 20. So I can just simply work that out, and then from there I can go on to solve for the unknown. So this is going to be equal to 0.94 app f app minus, I can bring the whole lot across, 0.4. This 50 times 9,8 is equal to 490, minus sine 20. If you put that into your calculator, sine of 20 is equal to 0.342. So 0.342 multiplied by f app gives me whatever it's going to give me. All of that's going to be equal to 0. So when you now put that into your calculator and then you work it out, you will have 0.94 f app minus 0.4 times 490 is equal to 196. If you put that into your calculator, is equal to 196 minus 0.34 f app. Collect like terms and then solve for your unknown. So if you move that to the other, so this becomes a plus actually, because if you were subtracting and then multiply a negative multiplied by negative gives you a positive, and therefore it's going to be equal to 0.94 plus 0.34, so plus 0.94.94, it gives you your 1, is it 1.28? 1.28. So this is 1.28 FF is equal to 196. So if you divide that by 1.28, then your FAP is equal to 196 divided by 1.28 is at 153. Just check that everything is being calculated correctly. So is this 153 comma 125? Just quick check just to make sure that all the substitutions, all the calculations are done correctly. So 0.94 for the force applied. Then when you transpose that to the SI, becomes a minus 0.4 times 490 minus 0.34 FAP is equal to that. And so the sine of 20, just to cross check, sine of 20 degrees is equal to 0.342, 0.34, right, is equal to 0. And then so if you transpose the 196, what I didn't do, there's an error here. Whilst I multiplied this by the 0.4 times 490, I did not multiply the 0.34 by 0.4. So that means that is incorrect. I sensed that there was something that was amiss. So that is incorrect. So 0.34, so it's 0.34 multiplied by your 0.4, that should give you 0.136. So this here should be 0.136. And so when you add your 0.94 plus your 0.136, the answer is 1.076. So the answer here should be 1.076. 1.076. It's 1.076. FAP is equal to 196. So if I divide both sides by 1.076, 1.076, 1.076, so 196 divided by 1.076, divided by 1.076, the answer that you will get is 182.16. 182.16. So the answer you are expecting to get is 182.16 newtons. So that would be the size of the force that is applied. The next part that is asked of you is to calculate the normal force. Remember, there are components that are acting or influencing the normal force that is being calculated, and therefore it is important that you take that into account. The normal force in this case is going to be calculated as follows. So 3,4. So it's Fn plus the vertical component is going to be equal to Fg. The Fn is what you are being asked to calculate, and the normal force, that's the normal force, plus the vertical component is equal to the force applied times sine 20. So the force applied is 182.16. Sine 20 is equal to Fg, and Fg is equal to 50 times 9.8, which is 490 newtons in the downward direction. So your Fn is going to be equal to 490 minus 182,16 sine 20. Put that into your calculator and do the necessary calculation. 182,156 multiplied by sine 20, so that's 62,3. So it's going to be equal to, so it's going to be equal to 490 minus 62 comma 3 newtons, and then when you subtract that, it's 490 minus 62.3, and the answer that you're going to get is going to be equal 427,7 newtons. So the answer to that is 427,7 newtons. That is the value of the normal force that acts on the object that is experiencing the force, 427,7 newtons. The next question is question 3,5. You are asked to calculate the magnitude of the frictional force. The magnitude of the frictional force. So the frictional force, we know Fk, so that's 3,5. The magnitude of the frictional force is equal to mu k times the normal force. So that is the normal force. We now have the normal force. So we want to calculate the frictional force. So it's the mu is equal to 0,4, and then the normal force is 427 times 427,7 newtons. So we multiply that, and then you'll get our the magnitude of the kinetic friction. So it's going to be equal to 427,7 multiplied by 0,4, and this is going to be the size of the frictional force that is acting on the object as it moves. So the answer is going to be equal to 171,08 newtons. 171,08 newtons. So this this kinetic friction that is acting on the object is going to be equal to 171,08 newtons. Then the last part that is asked is the same constant force is now applied to the block over the same horizontal surface as before, but in the direction that is shown below. Give a reason why the block will move slower than before. Give a reason why the block will move slower than before. So now when you look at this expression, what do we have? So now when you look at this object, what you observe now is that the force that is applied is now acting in a downward direction, as opposed to the previous scenario in which the force that was applied was moving in an upward direction. So now what that means is that what is going to happen is that the F normal is going to increase, because that whole vertical component is now acting in the Fx. The Fy is no longer acting in the upward direction, it's acting in the downward direction. So the F normal is going to increase. So that's the first thing that you need to understand. F normal increases. So if the F normal increases and the mu remains unchanged, what's going to happen is that it's going to result in an increase in the frictional force. So once the frictional force increases, it means it's going to become more difficult to move the object forward. Making it more difficult to move the object forward. Remember, the applied force is now no longer acting in the upward direction, it's acting in the downward direction. Therefore, when you look at, if you were to look at the free body diagram, you'd say, okay, fine, what forces are acting? You'll have the horizontal component, you will have Fg acting downwards, and you would also have the Fy now acting in the downward direction, and then your Fn is going to be in that direction. So your Fn is going to be equal to your Fg plus your Fy. So that means the value of Fg that you had, which was your 490, plus the Fy component, which is going to be that. So it's going to cause that Fn to increase, and hence, and then Fn, if Fn increases, your Fk, remember, is found by saying mu k Fn, or the mu k multiplied by the normal force. So now that normal force is high, therefore the 0.4 times that normal force is also going to be high. Hence, it's going to be more difficult to get that object to move forward, and therefore the object will not move any faster. Thank you for watching. If you have comments, please add your comments. Like, subscribe, and share this video with as many of your components of your associates as possible. Thank you very much.